everyone, welcome back to the series. In the previous video, we successfully connected our Spring Boot application to MySQL database using the JPA dependency which we added. But right now there is still one big question in front of us, that how does Java actually store data in the database? How does a simple Java class become a database table and many more? So in this video, we are going to answer all these questions in a simple and practical way along with doing the coding for it. We will learn that what are JPA entities, how Java classes map to database tables, how fields become columns, and much more. So by the end of the video, you will clearly understand how real world backend system manage data. So let's get started. So here the first question that we have to answer is, what are entities? So let's start with the most important concept here, that an entity is a Java class that is mapped to a database table. So what that means is that we create an object of that class. It can store data, and that data can be stored inside the database using that object of the entity class. So instead of writing SQL manually, we will just work with the Java objects of the entity classes, and JPA will automatically convert them into the database records. So now let's get started with the coding part. Okay, so now here let's create a entity package over here. So inside this package, we will be creating all the entity classes for the given application. Now here the first entity let's create, let's say it is user entity. So now this will be the user entity. Now let me define the user entity here. Now all the entity classes are annotated with entity annotation. So this entity annotation tells JPA that this particular class belongs to a JPA entity. Okay, so now let's understand this step by step. So first we use entity annotation. So this tells Spring Boot that this class should be mapped to a database table. So this mapping is done by the JPA dependency that we have. Now by default, the name of the table is same as the class name. Next, here we can see that we are using the ID annotation. So this tells Spring that this particular parameter or column in the table will belong to the primary key of the user entity or user table. Then we are using the generated value annotation. So this tells Hibernate to actually automatically generate the ID. In most cases, we use the identity strategy as we are using here. So that means auto increment in the database. Then we have normal fields like name and email. So these will be the columns in the user table. Okay, so now before running the application, let's check the MySQL database. So here we can see this is our database, Spring Boot tutorials. So here we can see in the tables, we don't have any table created as of now. So now when we run the application for the first time, it is expected that user table will be created along with these columns in the MySQL database. So now I am running the application here. So let's see. All right, perfect. So now if we see here that the application has started successfully, so that means the JPA would have created the users table in the database. So now let's go to the MySQL workbench. Now here if we refresh it, we can see that Spring Boot tutorial has this users table now created. So this table is automatically created by Spring Boot when we have run the application. So now if we fire this query, we can see successfully that these three columns in the users table are now created. So now we can understand the mapping of this user class with the users table in the MySQL workbench. So this is how the mapping will look. So for the user class, we can see the Java class has these three variables which are ID, name and email. So these will be directly mapped with the columns in the users table in the MySQL database. So ID will have the begin data type and name and email will have varchar as per the MySQL standards. So this whole mapping process which we saw here between the Java objects and the users table or the MySQL table is called as ORM, that is object relational mapping. So now the overall process which we saw, so by default it runs automatically, but in real world projects we often need more control. We need to customize the table names and column details. So now here itself if we see that, let's say we need to customize the column name for the name column. So here we can add at the rate column annotation like this. And inside the column annotation, we can specify these properties like name. So now the column name in the MySQL will be username and nullable becomes false, which means that this column cannot be null. So that constraint will also be added to this column in the database also. Also, we can add unique constraint to the email like this. So now the email address for each row in the database needs to be unique because we have made unique equal to true. So now if we run the application, these changes will reflect in the database as well. So till now we have understood the basic structure of an entity and some common annotations which we use to define the column properties and also the generated value for the primary key. Now comes the most important part in the entity mappings. So that is introduction to the relationships between entity. So in the real world applications, we don't have just one table, we have multiple tables and those multiple tables have relationships between them. Now, for example, here we can see we have one user table. Now, user table can have multiple orders. So as one user can have multiple orders, there will be one relationship between the user table and the order table. So now before that, let's create a order entity here as well. So let's name it as order. Now order classes created in the entity folder. Now, as here, we will be using one-to-many relationship between user entity and order because one user can have multiple orders. So for that, we need to define the relationship entity class itself. So in the user class, we will define this one-to-many annotation which will be mapped user. So this user is the variable name which we define order entity. This variable is mentioned here in the mapped by variable. Now here we can see list of orders. So as we can see, list of orders is present with the relationship meaning. So each user will have multiple orders. That so we have a list of orders here, and inside order a single user because this is many one because many orders will be mapped to one user, but opposite is not true. So this is how many relations in the JPA entity. All right, so now let's quickly understand some very important concepts. So first one here we can see is lazy versus eager loading. So as the name itself suggests that by default the relationships are loaded lazily. So that has a very important reason. So lazy loading means that the data will be fetched only when it is requested. That means whenever we try to query that particular data, only then the data will be fetched. The whole entity will not be fetched at once. So this mainly improves performance of the application. Now, the second important concept, if we see here, is cascade. So, cascade defines what happens to the child data. Now, what is child data? So, here, for example, as we saw that we have a user entity and order entity. Now, if a user is deleted, should all the orders also associated with that user be deleted? Now that is an important question, and that is controlled by cascading. So if we set cascade as true, in that case the child data will also be deleted. So in some cases we want to do that. In some cases we don't want the child data to be deleted. Now the third concept comes here as the infinite recursion problem. Now here, as we saw that inside the user entity we have the orders entity list, and inside the order we have a user entity. Now when we return data as JSON, sometimes what happens is we get an infinite loop. So users will have the orders entity or list of orders basically, and inside each order we will again have the user, and each user will again have the order entity or list of orders, something like this. So this will be a recursive problem because when we are trying to get a user, it is returning list of orders as well, and each order will again have the corresponding user, which will again have all the list of orders. So this will be a infinite loop. So this can be fixed by @JSON ignore annotation, or so basically these few annotations are used to solve this issue, that is the infinite recursion problem. Okay, perfect. So now let's run the application again and see if the order table is also created and the mapping is successfully defined in the MySQL database as well. Okay, so now if you run the application, you might get some errors like this. So to fix this, simply add @table annotation in the order and mention the name as orders, because the order is a reserved keyword in Spring Boot. So if we don't mention the name as something other than order, in that case we get these errors. So now let's rerun the application again. So after rerunning the application, the error should be gone now. Perfect. So now we can see the application is started without any errors. And also here you can observe that as we discussed about ORM. So here Hibernate is using the ORM to maintain the relationship between the Java entities and the MySQL database. Okay, anyway, so now we can see that as the application is started, so in the database level, if we refresh here, another table should be created in the Spring Boot tutorial schema. So we can see that the orders table is also created now. So now let's run this query. Perfect. So here we can see that orders table is also created, and here we have the user ID column as well, which will be the foreign key inside the orders table, which will refer to the users table. In this video, we have learned that what are JPA entities, how the Java classes map to the database tables, how to customize the tables and columns as per the business requirement, and how relationships like one to many and many to one work in the JPA entity manner. Now, this is one of the most important concept in backend development. So in the next video, we will move on and we will use these entities to perform real database operations using the Spring Boot JPA repositories. We will create, read, update and delete data from the MySQL database without writing any SQLs. Simply, we will be using JPA, and JPA Hibernate will be handling everything in the background for us. So I'll see you in the next video.